All right. So, um, today we're going to spend most of the time on assignment 4 and working on that, getting you started on that. But before that, we're going to do lesson 4.7, which is mainly me just talking to you for a little bit. It's not that active, unfortunately. So we'll do that. And then we'll do the assignment 4, and then hopefully on Friday, we'll try to finish up the rest of these stuff. So let's look at 4.7. This talks about pseudo-random numbers, or well, random numbers, but in the computer, we can't really generate random numbers. It's very hard to do that. At the bottom of the thing, they actually have this link to this actual physical site that uses these lava lamps which work quite randomly and actually generate random numbers for companies using the lava lamps. So there are some ways to generate random numbers, but not easily here. But we're going to look at what the computer does as far as pseudo-random numbers for this stuff. I'm just going to bring up these slides and walk through them relatively quickly. Okay. So again, what we're going to want to do is generate a sequence of random numbers here, at least that. So the idea is that we would have this, and again, I don't love their acronym there. PRNG is pseudo-random number generator. Pseudo-random number generator. That's what they're talking about here. So we're going to look at that. And that's what like this block does. When we say generate a random integer from 1 to 100, that uses a pseudo-random number generator. So how does this work? So the idea is that if we provide it some value, like the last number generated, it will generate a random new number kind of based on that with some math. And we'll look at the math that we're going to use to do that. So a simple way of doing this is we'll take the old random number 10, multiply it by 2, and add 1. Okay, so 10 times 2 is 20, plus 1 is 21. So that gives us 21 there. Then we can take that number and add it and do it again. And so again, we can kind of talk about this this sort of notation that we see fairly often in math and stuff, where we say x sub I and x sub I plus 1. So x sub I is our current number. So that'd be like 10. And then we calculate x sub I plus 1. So the next value in our list of values. So if we're at the third value, this would let us take the third value and calculate the fourth value in our list. So it's just a notation that is commonly used. So again, if we have 10, we run it through an equation, we get 21. If we have 21, we run it through our equation. 21 times 2 is 44. 42 plus 1 is 43. Yeah, I did that right. 43 there. And then again, now we're going to take that 43 and put it over here on this side. 43 times 2 is 86 plus 1 is 87 here. So again, we're just going to take these numbers, whatever the new number is, we're going to take that and put it into the equation again. So here's our sequence of numbers for that we have. You may notice this doesn't look very random. 10, 21, 43, 87. If I asked you what the next number is, you could guess at it pretty well. I mean, it's probably going to be pretty big there. They keep getting bigger and bigger. So maybe 160, something like that, range there. It's probably not going to be, 4, and it's not going to be 2 million there. So it's not very random there. So we're going to have to make this a little more random. And so we have to talk about modular arithmetic, which is sometimes referred to as clock arithmetic here. So what is clock arithmetic? So what time is it now? It is 1 o'clock. What is 18 hours from now? So 1 o'clock plus 18 hours. So that'll be next tomorrow. So 12 hours would be 1 o'clock tonight there. So 18 hours would be what, 6 o'clock in the morning there? 7? Yeah. So when you're adding here, what we do is you kind of go in a direction. If we're at 1 here and we add 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is 7 here. So again, we go around the clock for this. And that's a special type of math, and we use a mod operator for that. So, and again, some places will use a 24-hour clock, some places will use a 12-hour clock, but it's the same sort of idea for this stuff. I'm going to skip over. Okay, so in math, we talk about mod or module arithmetic here. So we'll do basically what you do with mod is it gives you the remainder. So if you say, I want it's 11 plus 20 mod 12, what you do is you give, you would take this, 11 plus 20 is 31, and then mod 12 would be a remainder. So you take out the 12s from this and figure out how much is left. It's kind of another way I think it was doing change there. And how much, if you take out a 12, you take out another 12, how much is left? Or when you do long division, how it works for that. So I'm not going to go over too much on this, but you can watch and review it on your own if you want. So here's our updated equation. So we're going to take our current number, multiply it by 2, add 1, and mod 13. So that means we're going to divide it by 13, give a remainder. When you mod by 13, you're going to get either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. 0, again, like if you ask for the time, it's 1 through 12. Again, we are going to start 0 for this instead of 1 here. So that's what we're going to do. So let's do that. So if we start with 10, 10 times 2, 20, plus 1, 21, mod 13. So 21 divided by 13, it goes in there once, and the remainder is 8. So our result is 8. Now we're going to take that 8 and run it through here. 8 times 2 is 16, 17, divide by 13, get the remainder. So what I was at 17 divided by 13, and really we can also just subtract 13 there. So 17 divided by 13, we take out a 13, we're down to 4 there. And then now we have 4. And again, this is what our random numbers look like. And this looks a little better, a little more random for this. They seem like they jump between 0 and 11, more random. Of course, again, we might want numbers between more than 0 and stuff. So again, we can change what mod we want to do. And we might want to use some bigger numbers here for this stuff. So this is what we often do is we'll take whatever our number is, multiply it by some number we call A, add in some constant we call C, and do a mod of M for this. And we will tend to pick maybe a little bigger numbers for that there. So A is typically 24 billion, whatever this number is A. C is generally just a constant of 11, And then the mod is 2 to the 48th, which again is a really big number for that. So those are what we often use for our random number generators. The next question is what number do we start with to start our sequence? Because one of the things with random number generators is if you know one, you're going to repeat. So like here we go 10, 8, 4, 9, 6, and then we start, and it's when we hit 10 again, it's predictable. It always goes 10, 8, 4, whatever. So if you know where you're starting, you can, or if you start at the same time, I don't know, have you ever played a game like that where every time you played the game, it ran the same way? Like we're just talking about old games. Some of the old games were that way where they, like Pac-Man, if you move the same way, everything worked the same way on or the old versions of Pac-Man. They had random number generators come sometimes, but again, it wasn't that random for that stuff. It was predictably random, which isn't that good for this. So what we often do with that is when we're picking our starting number, we will pick something with the current time, like the current time down to a millisecond there. So that if you start and then a minute later you start again, it'll be a different time and you'll start at a different starting number and you'll generate a whole different sequence of numbers. And again, there's not just 11 here, there will be 2 to the 48th, billions of numbers that you're generating. So you won't repeat very often. Okay, let's see so again, they walk you through some exercises here with that, and then self-check. Yeah, we do Dilbert, and are slot machines fair? Why or why not? So you might want to look, there's this video on slot machines there. It's interesting because, I don't know, we could program, and sometimes you do this where, remember we were flipping coins and you said half the time it was, so you got either a 1 or a 2. You can make fake coins on the computer there. It's not that hard. You could like generate a number between 1 and 10, and maybe you wanted heads more often. So if it's 1 through 7, you'd show a head. And if it was 8, 9, 10, you'd show a tail. So it would just be heads more often, and then you'd win more. So casinos would be interesting, would want to set up their slot machines so that was in their favor there. But so again, someone's got to regulate them and control, and they've got to prove that their slot machines are random, although being random doesn't mean it's fair. You're still probably going to lose money. They don't have to set it. They can set it up so it's truly random without still giving them a slight advantage. So, yeah, is it possible to to find a method where you would consistently win at a slot machine? Good luck at that. So.
I mean, the other way to change the code in the machine.
Right. If you could hack the machine, there. Right. So, okay. Questions on pseudo-random numbers? Okay, so let's talk about the assignment. I want to get you started on the assignment because it's a little more complicated, I think, this time. We're trying to look at models of the real world here and how computers will do that. And I created this model a few years ago when we were in the pandemic, and I wanted to show you this. So I'm just going to go into this worksheet there. We want to open this up in App Inventor. There's an AIA file here, so I'm going to click on that, and I'm going to download the AIA file. So download the AIA file somewhere. I'm just going to store it in my downloads folder. Then I'm going to run App Inventor. And in App Inventor, I'm going to import an AIA file. So import project AIA file, choose the file. I'm going to go back to my downloads file, wherever you downloaded it, find it, and open it up. So in this one, you don't have to do that much coding. There's a lot of coding in place here. So we're just going to try this out. I'm going to just put it on my phone to start with. I suggest you try to do the same thing and see what it does initially. Okay, so I'm going to connect it up. And my QR code. So idea here is where we have these little simulations of people being infected and infecting other people. You can restart this. So here I'm starting with one person that's infected, and this person right now doesn't infect others very often there. But I can click on set parameters, and there's some be different parameters. So I can change, for example, I have the size of the little ball is pretty big. I can make the speeds a little bigger if I want. I can also I can change a number of things. The transmission rate, the injury rate, the death rate, and then the length of the infection. So I can make the transmission rate so it's more likely that they'll get transmitted. Increase that. Go back here and restart the simulation. And so again, depending on what these are, so the simulation will run, and anytime one ball interacts or hits another ball, it will check if it's infected. It'll see, basically roll a dice, pick a random number, and see if it will infect that other ball as we go for this. And then you can set these different parameters. So see if you can get this running and try out different types of parameter values here and see what you like. See how they seem to you. And again, once you do that, you can hit restart to restart and see if it changes. Because again, it's going to be random every time that you do this. Are they on your apples? What is it doing?
It's just bad here. Just very glitchy.
Very slow, huh? Yeah. Um, yeah, let's see. I'm just going to talk a little bit about the code here, what it's doing. Um, and most of this code you don't have to worry about here, but you can kind of see we have where we initialize the list. And we also initialize some timers. So we have a timer, a bunch of timers going off for this. And you can see we have a whole bunch of balls that here. If yours is really slow, one thing you can do is you can delete some of these ball when we're initializing the list. So it's not necessarily moving those balls. I'm not sure if that will help, but it might help with that list. Every time a timer goes off, we go through this list where we go through and loop through all the people, all the balls, that we're simulating for each. So we have a big loop, and for each one, we're checking. It has a countdown timer. Every object has a countdown. So if it's infected, it will stay infected for so long, and then it'll become recovered, stuff like that. So we have some calculations based on that here. And we have our initialization screen. We actually are getting all these values from a tiny database so that when you quit and run it again, it'll remember where your values are stored for this. Okay, so what do we want you to do here? We want you to try out some of the simulations here and check out some different values for things. So again, you can change the transmission rate, the death rate, the injury rate, the ball size, the ball speed, and the length of the infection here for this. And your job is to figure out something you want to try to simulate here for this. One thing I did tried is like, what is the difference between if everyone during a pandemic could wear a mask or not for this? And then you have to ask, well, what if someone's wearing a mask or someone's not wearing a mask? How is that different? Which of these things would that affect? Would it maybe affect the transmission rate or the length of the infection, the death rate, the ball size? So one thing I did here just to visualize, I said, well, if you are not wearing a mask, maybe you're spreading infection around in a little bigger area. So I had the balls just be bigger. So without a mask, the balls were smaller. With a mask, they were bigger here for this. And then you could try the simulation either way for this. So your job is to decide that. And you want to modify the code here. Oops, we gotta go back here. You might try things out, and then you want to remove the set parameter button, or at least that code here. So let's see, where is that? Here's the set parameter button, opens up another screen. So we don't want to open up another screen when we want to set this. We want to have buttons that do different things. Like, for example, here, let me see if I can zoom in because it's hard to see that. Let me see if I can. So here, right now, we just have a restart and a set parameters. We want to get rid of that set parameters one and add, like here in this example, we had mask, no mask here. And maybe you want to do, you can figure out two things you want to simulate here and run the stuff on. So maybe it would be if everyone is vaccinated or not, or maybe you'd have two different variants because like the variant we have nowadays is much different than the variant we had in early days of the pandemic. And you want to maybe show that the current variant is different and it spreads differently than in the early days here. So you want to figure out something there. And again, add two buttons here that would be different values. So replace this one with two different ones. So again, you can go in here, go back to the designer. This is my set parameters button here. I'm actually going to leave that there. I'm just going to add another button to that. And again, maybe I'll do two different things. So, I mean, and then decide what you want to simulate for this. And rename your two buttons for this. So, and then do your code for that stuff. So see if you can do those values. There's a bunch of variables here that are set by default. You can reset those. You can just hard code them here for this. And again, in your buttons, you can reset them to different values. So these are your the global variables that you can set here. Is this making sense? I'll let you think about what you might want to simulate here and try that out. And then we'll talk a little bit about how it goes and what problems you might run into in a little bit. And one other thing I was just mentioning is that when you do your simulation here, you can remove the TinyDB here. So we don't necessarily have to store anything in the TinyDB there. So if you want to, particularly the screen initialize here where we are getting everything from the TinyDB, you can just delete all of that stuff. Drop it in. Where's my trash? Oops, drop it in the trash. And just call reset simulator. So again, so basically what you'll want to do is when the screen initializes, just call the reset the simulator. You want to do something with the two buttons you have to set some parameters. And here's your initial parameters, and you can change those, and you can also reset them when you click the button to run the simulation in different ways. So. Here's an example of what you might want to do. Well, I don't think you want to do this, but I was thinking I've been thinking of Halloween. I'm decorating for Halloween probably tonight or tomorrow. And so it got me thinking zombies. So I was thinking zombies are not something, well, what's the opposite of zombies? I think maybe just the flu. So I made a button for zombies and a button for the flu. So if you hit flu and hit start, you just have one person with the flu, and there's a slight chance they'll infect someone else, but then the flu goes away. But if you go to zombies, now in my world, zombies are very slow. I know there are apparently some places where they have fast zombies, but that doesn't seem right to me. Zombies to me are very slow there. So we have slow moving zombies. But once you run into a zombie, it's bad in general. So I have a really high infection rate for zombies. I always think everyone who gets bit by or gets attacked by a zombie becomes a zombie, except for maybe that one, the main character in the movie. That person maybe won't. You need that one person there. So then the zombies slowly take over the screen for this stuff. So again, that's what we want, is we want you to have two buttons and code for that where you can set these things up. Now, there are things, one thing you probably want to start thinking of is there stuff I can control? And is there stuff there's probably stuff in the simulation that you wish you can control that you can't here. For example, for zombies, I would like the zombies to be slow and people aren't zombies to be fast. There's only a ball speed. You can't differentiate between one thing and the other. So there are certain limitations to this. But play with this. And again, you want to write up and do this reflection about these things. One thing to remember is that we have scientific estimates for things like the death rates or the infection rates. So when you're in the same room as someone with a certain disease, we have pretty good calculation of what the infection rate is for those. And the question is do you need to be using those? Should you use those in the simulation or not? And is there good reasons to use them, and are there good reasons to not use those? So think of that. I'll go around and help you. That's all we're doing today, is trying to work through the simulation. So I'll let you keep working on this. What?
Just answer the 3
Yep, answer the 3 questions and you're good. So, okay.